Hello there. Sorry about the breakup for the video there. In that last video, I just had a message flash up on my screen that my computer was about to shut down. So, uh, stemming the panic, I just had to close off very rapidly there. So let's continue then with the problems we're looking at. Just one more to look at. That was the third one. And looking at the spectra, there are three potential um, targets here that we could consider. Looking at the peaks above 300, it could be suggestive of an amine, it could be suggestive of an alcohol, or maybe a carboxylic acid. But when we think about it more clearly, we could rule out the alcohol because the alcohol, although it's broad and in this region, it doesn't have these little spikes or this little crab claw kind of hand. That's not what an alcohol does. Nor is it what a carboxylic acid does either. It doesn't form into a crab claw, and even if it did, it's in the wrong region. The OH stretch for a carboxylic acid imprints over the top of the CH stretches for an alkane. So it's the wrong shape and we're in the wrong position. So it can only really be an amine with those peaks in the 3300 to 3200 range. We've got symmetrical and asymmetrical stretching of the nitrogen to hydrogen bonds. And with the two peaks, it's telling us it's a primary amine with two nitrogen to hydrogen bonds attached. So that's really the main stretch that we're seeing here. The nitrogen to hydrogen bonds, one each. The peak at 1603 is also for the nitrogen to hydrogen bond bending vibration. Again, very distinctive for the amine. So if we look at the molar mass, that was a molar mass of 73. We can take into account the mass of the nitrogen itself, leaving us with 59 grams, which should be just carbon and hydrogen. So we divide by 14, because it's usually a 1 to 2 ratio for carbon and hydrogen. That goes in neatly 4 times and leaves us with 3 units of mass. And that 3 units we can easily explain with an extra 3 hydrogens. Now notice that that puts us beyond what we'd normally expect our saturation limit to be when we've got 4 carbons. That is that an alkane would be CnH2n plus 2. So carbon is 4, the hydrogen would be 10 at most, but we're up at 11. But it's the presence of the nitrogen which explains that. With the nitrogen replacing one of the hydrogens at the end of the molecule, the inclusion of the nitrogen instead of one hydrogen gives us two more hydrogens, one more than we'd normally expect, and so it creates that odd number for the molecular ion peak. That's also very distinctive for nitrogen containing compounds, an odd number for the molecular ion peak. So we could probably estimate it to be a secondary substitution on the main chain for our primary amine. That's backed up by the mass spectroscopy because we've got a fragment at 58 which looks like the carbon to carbon bond here has been broken, alpha cleavage on the left side, and the peak at 44 also suggests alpha bond cleavage on the right hand side. So it looks as if this is indeed a molecule. Okay, I hope that helps and good luck for the exam.